Hello and welcome to our project 2 for numerical methods 2 for the spring 2019 semester with Dr. Menezes. This project 2 is a continuation of project 1 where we solve for the velocity heads. Here we will find the way the contaminant flows with the velocity heads for our designated area. The name of this project is Groundwater Fate and Transport. To begin this project, you will need to have the following file open, MATLAB Proj 2, and be sure to have the following MATLAB codes as well. Your SolveMat, MyCramer, and Gaicedo as well, as you will use these three options to help you solve for your system of equations. Okay, so before we begin, it's important that we discuss the boundary conditions for the concentration and constant head boundaries. So for the similar to project 1, our boundary conditions for the head boundaries are 0 is an active node, 1 is a constant, -1 no flow, and 2 is where you will have a pump or well. As for the concentration values, concentration boundaries, D1 is a active node, 2 is considered a constant, 3 is a no boundary, and 4 is considered your infinite boundary. Okay, so now that the boundaries have been discussed, we can go ahead and move on to running the code itself. So we can go ahead and exit out of the Excel files, open the AP Proj test. Here you redirect to the MATLAB code, and make sure that you also open the AP Proj test MATLAB file, not the GUI file. So for this, all we have to do is just run the code. You redirect it to the terms and conditions. Be sure to fully read the terms and conditions to make sure that you have a fully understanding of the conditions for this code. Once they are accepted, you will be redirected to the GUI, and we can now begin to enter our boundary condition file, constant values file, concentration boundary file, and initial concentration file. So to begin that, we can just go ahead and click on the push button, insert your head boundary file, click the option for constant head, and enter the constant file. For your concentration boundary file, go ahead and enter that as well, and the initial concentration values. So we can now begin to enter some values. For the distance of elevations, we're going to put 100 feet. Our hydraulic constant is 10. Our transmissivity value is going to be has to be really small, so this is going to be 0.0002. For our porosity, it's going to be 0.1. Our hydrodynamic dispersion is going to be 1, and our time is going to be in days. So it's just for how long you want to look at the contaminant flow through the area of study as it merges into the water. So we're going to look at a 100 day in increments of 1 day. Okay, and we also integrated 4 methods of solving for the system. By entering a 1, you will get a Gaicedo method that we developed. By entering a 2, you get the SolveMat method that was also developed in class. 3 is Kramer's method, and 4 is the MATLAB's integrated function for Gaicedo, which is the fastest approach. For time purposes, we're going to use option 4 because it does take some time. So to begin, we'll go ahead and click on the first push button, which is ready to find groundwater flow. Click on that. Here you can see the velocity profile and groundwater flow. By clicking on the options on the upper left-hand corner, you can rotate these options here. You can see here we have a small pump and a well, and it's just also describes the method. And then once that's complete, Okay, and then then you can click on the area to find concentration. So go ahead and let's go ahead and click this. And here you can see at 12 frames per second, the contaminant begin to spread into the area of study. And let that complete. And there you go. It is completed. Once everything is done and you're happy with your values, you can go ahead and click Save Files. And here you can create your own folder. So we'll call this Proj2. Select folder. Oh no. Oh, cancel. So let's go ahead and save this in our downloads to our documents. Our downloads. Select folder. And then here you can name each of your heads, each of your files. The groundwater head, velocity X, velocity Y, and concentration, final concentration values. So to conclude our project, we were able to successfully find the contaminant as it spread through the selected area based off the velocity profile and groundwater flow. We can go ahead and name these files. Groundwater is heads, velocity Vx, velocity in the y direction Vy, and concentration, final concentration. Once files are saved, we can go ahead and look back on our computer, and we can see that they are all saved in as a Excel file. So thank you again for your time, and I hope you enjoyed the video. Have a nice day.